I'm Stephen Foskett. Welcome to Tech Field Day, coming to you November 2016 from Silicon Valley. We're here with StorageOS and the delegates that we've brought in from around the world. These are folks who specialize in servers, storage, networking, and they are intending to be part of the discussion that you're about to see. If you'd like to learn more about Tech Field Day, come to techfieldday.com. And if you'd like to see more videos like this, just go to youtube.com/techfieldday.
Thank you for joining us. Hi, my name's Chris Brandon. I'm here with my co-founders, Alex Chircop and Simon Croome. And what we wanted to do is give you a little overview of how StorageOS works in the real world, to give you context of the architecture and technology discussions that we're going to have afterwards. So Simon is going to drive a little demo. Simon, if you give a view of this infrastructure, what we've done is we've built a storage array that runs at the application level, a full enterprise storage array, and it runs on whatever infrastructure sits underneath that. So that can be a virtual machine, that can be a physical bare metal server, a hyper-converged infrastructure, or a cloud environment. And Alex, Simon, and I all came out of the London banks, and we want to talk about a common day and the problems we've seen and how StorageOS can help solve those problems in a real-world scenario. So if we pretend I'm the CIO, and I've got lots of very demanding customers. I've got compliance and service level issues that I need to focus on. And we've built, with Alex, my head of storage infrastructure, who in his previous life was the global head of storage for Goldman Sachs. And we got Simon here, who runs my development team. He did that for Fidelity and Nomura before he joined us. So, and
before we start this,
yeah.
This is a cheesy role play. You haven't been to drama school, so don't criticize us for the acting.
So
I'll put the Oscars on.
Polish it for me, please. So if you look at an organization, we've got a production team, a development team, and an ops team. And we're really trying to get this up and running. So the scenario we have here is that I've got a business user that wants to get a Postgres database supporting a website up and running very quickly. And we need to do that in our environment. So Simon, what do you think? How should we do this?
Well, this sounds like an ideal application to deploying containers. So, I know that traditionally in our enterprise we haven't used containers, but I've set up a Docker environment on a 3-node cluster. So we're pretending this is running in virtual machines in a farm someplace, but really it's just running on my laptop at the moment. So I'm running a 3-node Vagrant cluster using VirtualBox with a bit of SSD storage presented into the virtual machines.
So normally when a new request like this comes into a traditional organization, somebody's going to have to figure out the requirements for the storage, figure out which storage array they're going to provision out of, and then figure out how to present the storage to that particular cluster. And that's normally can be a painful process. And really nice organizations, it can be a couple of days, but it's traditionally a couple of weeks and can sometimes be months.
So being the developer type, I just requested a few VMs and I installed the StorageOS container on them. And I'm able to then see the UI here. And you can see that I've got a 3-node cluster. And each of the cluster nodes can see a bit of storage. So 90 gigabytes each. And basically it can take that storage and re-provision it out. So basically with that storage, we create a distributed storage pool. So you can see that I've got all three controllers in that pool. And it's aggregating the storage from each of those controllers.
And Simon, you haven't had to make any changes to the underlying infrastructure to do
Absolutely not. This is just using the local storage on the available on the Docker host in the VM.
But so how is the data managed?
Well, you can tell that, say on this pool, I've got a couple of labels. So I've got production in London. So StorageOS has this concept of labels. much like Docker and Kubernetes does, where you can tag any object within the system. So it could be locations, applications, environments. So for example, for the environments, I've got dev, prod, and UAT. But it's also for features. So StorageOS manages its own features as labels. So I can assign one of these feature labels to an object, like a volume, and automatically that feature is activated on that volume.
Okay, well, that sounds fairly simple, but how would we manage all the normal stuff? Like, how do we do DR and encryption and replication?
Well, this is where the storage administrator, well, you as a storage administrator would know more about this than I would, but basically you can set up rules. So out of the box, it comes with a default rule to enable compression. But say, for example, you wanted to say that all of your production data should be replicated, you would create a new rule for it. So I'll create a rule for production replication. So what I'll say is where a volume has the label production, I'm going to add a feature label called replication. If I save that, so now when I create a volume, that volume should automatically be replicated. Well, a volume with the production label. So let's try that. So if I create a new volume, so I will add my labels. So production, this is going to be Postgres, and we're going to run it in London. So you can see also the volume name has been auto-created based on templates we've defined elsewhere. I use the standard 10 gigabytes in the default storage pool. When I create that, you can see that it's added the default compression label, and it's also added the replication label. So it's provisioned the master to the node StorageOS 3. If I show the replicas, it's provisioned the replica to StorageOS 2. So
and it does all of that automatically?
That's all done. That volume is ready to be used.
And you can do things that are business related as well?
Absolutely. So we can assign labels to clients that are connecting into the system, mounting the storage. It can be on volumes. It could be on the servers presenting the storage. It could be anything, any object within the system.
And can you use labels to group business units or different departments?
Absolutely. So you would be able to go in and create your own, say, for example, you wanted to create a new label, grouping for business units. You would create a business area. If I can spell that. Business area, no. Business area, save that. And now within the business areas, we can create labels to say equities, or it could be compliance or whichever other groups. So then when you create a new volume, you could assign equities to that volume, and you could create a rule as well to say, well, maybe the equities data needs to be encrypted, and that would automatically set up the policy for encryption on that volume.
So far so good. It looks like a traditional storage array. How does this work with Docker, and why would you want to use it with your containers?
Well, so the developer would typically not even see this screen unless they're setting it up for the first time themselves. The developer experience for a developer is usually command line based, or they would automate the experience in like a Docker Compose file or Kubernetes pod. But I'll just show what a developer would typically do. So Control R. So a developer wanting to spin up a Redis container would type a command like this. So docker run, so they're going to name the container Redis 90. They're going to mount a storage volume into that container at /data. Here I'm calling the volume name Redis 90. The only thing they need to do differently from what they didn't do now is add the volume driver StorageOS. So this is a standard Docker feature. They should be comfortable with that if they're already using storage volumes. Redis is the name of the container image, and Redis server append only yes is the command that's passed into the container. So it's important that the append only yes tells Redis to actually persist the data to disk and not store it all in memory. Okay, so that's just started the container using a StorageOS volume.
Yeah, but has that actually created a volume?
Absolutely. So if we go back to the UI, and I go back to volumes, if I cancel that, volumes, yeah, there's my Redis 90 volume. So you can see that it's provisioned that on the StorageOS 1 node. That's the node where I launched the container. So our internal scheduler will always optimize placement of the data on the node where the container has been run, obviously for obvious performance reasons.
So I've deployed a database in minutes, and I've done that with all of the functionality of a traditional storage array, but in a container.
Absolutely, yeah. And we can run a benchmark on that, just a standard Redis benchmark. So basically, I'm just linking in it's basically the Docker service discovery mechanism to link in the Redis 90 database, call that Redis within the benchmark container so it can connect. And you can see that we think we get pretty good performance out of that. Bearing in mind that this is just all running on my laptop.
So this is just VMs with a couple of cores all on your laptop in a whole cluster, right?
Yeah.
So incredibly low latency and very high performance.
Yeah.
So you're just presenting the raw storage that container, that your StorageOS container can see. You're representing that as a Docker shared volume.
Exactly.
Automatically, as you said, co-locating that storage on the StorageOS container that happens to be on the same host as the Docker container that is accessing it.
That's right.
And so it's fast if the storage is fast, but it's going to be slow if the storage is slow, and it's going to be unreliable if the storage is unreliable. What else are you doing to the storage?
So we're going to go through the architecture in a minute.
Okay,
but fundamentally, it's the storage is co-located with the container as an optimization, but it's not a requirement. The storage can be on any node in the cluster, and you can have placement to optimize performance based on the different storage that's available in the different nodes.
And what kind of ratios would you be looking at for quantities of storage and amount of performance expected per container as you then start to scale that out?
That's a question that you have to answer, really, in the sense that the ratio of compute to storage varies between different use cases and different load profiles, right? So if you're using large databases, you might have a couple of containers and a lot of storage per node. If you're using maybe more web type applications where perhaps what you really want is to store a few gigs of logs or a few gigs of persistent caching for that particular web application, then the ratios can be radically different, where you might just have nodes with a couple of SSDs and lots of containers.
And where have you found typically the bottlenecks to start appearing as you start to scale it out? And where do you normally find pinch points?
So the pain points are generally going to be limiting the limits of the infrastructure themselves. So if you are trying to go out over the network, then obviously your network bandwidth is typically the bottleneck. What we've done is we've optimized the architecture such that CPU and memory is rarely the bottleneck, and it tends to be the access paths. So to give you an example, even with all the data services like encryption and compression and those sort of things, we typically operate in terms of gigabytes per second per node. So it's generally always the network that is the limiting factor.
Part of the process we're going through with our beta right now is to identify different verticals and different use cases in those verticals for the different database applications that people want to run in containers, and help provide the guidance and the empirical data around benchmarking so that people understand how to build and grow those environments as they start taking them into production. So we're helping customers do that work. It's not, you got to solve it all yourself. We're building that data pool right now and publishing it out to our user community.
And does that pricing model, is that based around the quantity of storage or the number of containers, or both?
So there's a cluster-based pricing. So there's a free version, and the cluster license includes a terabyte of storage, and then beyond that, it's capacity-based licensing.
You can run as many containers as you like to hit your capacity.
Yeah, completely.
And as many nodes as you like in a cluster as well.
So we want to encourage people to grow and expand their environment, and we want to have people pay for the value they're experiencing, like a cloud-based service, and that's what we're trying to do is really help bring that cloud-based service model to the enterprise container market.
And just one last question on that. Is that based on raw, or is that after deduplication and compression?
It's based on presented storage.
So essentially you've got a scale-out distributed storage array inside a container, or inside of multiple containers, right?
That's exactly it. Yep.
But for like this example, it's all running on that laptop. If you restart that laptop, what happens to your storage? It's gone, right? The containers will be gone, right?
No, because it's making use of the storage that's available to the containers. That storage is still available within the VM, so that the data is persisted on within the VM. So basically, we're sharing the devices or the file system into the StorageOS container. So when that container restarts, that data is still available.
So the container doesn't own the data.
Exactly. Yeah, it just operates on it from within the container.
Yeah, because even though people say that containers aren't persistent, they are persistent until you delete them or move them to a different host.
Yes,
Correct.
but because we're presenting the sort of either the raw devices or the file system into the StorageOS container for it to then represent out, once we write data on those devices, it's there. It doesn't go away when our container.
So it's even more
restarts.
persistent than typical container data.
Indeed. Yeah.
Yeah.
And then we're adding additional enterprise storage functionality on top of that, which Alex will explain in a minute.
Would the same process apply if you're running the containers on bare metal, in effect?
Yes.
And I take it you support bare metal in the same way you
We
support
We do, yep.
Yeah.
Yeah.
How's that data protected then? Is that something that you would do on the physical level, like RAID, or are you guys distributing it across
So
the
we have a whole section dedicated to how we protect the data, but just as a very high-level summary, we mix erasure coding and replicas and a number of sort of distributed protocols like Raft and Gossip to achieve that.
So on bare metal servers, you support fiber channel storage being presented to those stores, or are you just looking at bare drives on the server?
So our data plane virtualizes any storage that is visible to it. So it could be file systems, or it could be physical drives, or it could be LUNs that are presented to the box, or it can be virtual drives from VMware, or it can be EBS volumes in Amazon. So it's whatever the container can see, or whatever you permission the container to see.
And so we've said that the data itself persists even when an individual container dies.
Yeah.
What about like the metadata and all the control plane type of data? Where does that persist, and how many containers can you lose before you're at risk of losing the actual, the brains of your storage?
So for the control plane uses a key value store, and today we support console, etcd, and Zookeeper, and those systems are sort of battle-ready, production-proven systems. You can co-locate the key value store alongside our containers if you want to have a really small cluster, but many people who are deploying Docker clusters in Kubernetes typically already have some a key value store perhaps distributed across a number of racks.
So we provide an ISO install that deploys all of this for the customer that wouldn't know how to do that, but we also provide a container-based install for the customer that would already have that sort of container infrastructure.